Right, so again, the title is on the optimal allocation of resources for a marketing campaign. And this was a publication. It was done by Prof. myself and Inzamam, and it was presented at the 10th International Conference on Operations Research. Okay, so on the table of contents, we're firstly going to look at an overview of the area, and then we're going to dive a bit into the problem. Afterwards, we'll kind of formulate the mathematical workings of the problem and our solution that would eventually solve the problem. Afterwards, we'll describe some numerical results and we'll wrap up with conclusion and future work. Okay, so marketing is an important aspect of modern business in today's world, and businesses make use of a wide variety of approaches to market products to their customers. Now, some customers might be more likely to purchase a product or service than other customers. And it's quite often difficult to make a judgment on one customer in particular. So if we divide the customer base into segments based on their features, we can apply more refined marketing strategies towards a particular segment. And in doing that, we can actually make purchase more probable. So telemarketing is one of the most personal means to persuade customers today. Different customer segments can respond differently, however, to telemarketing. So some might respond favorably towards it, whilst some might not be interested at all. So we must be very careful that we don't irritate customers, since this might lead to unwanted outcomes. And campaigns must be designed with a limited budget of contact attempts in mind. So we would like to design an approach to a data-driven phone-based marketing campaign to solve the problem of determining how many calls or the optimal number of calls, that we could assign to each potential customer. So we're going to present a novel formulation to this problem. And we examine similar research, and the majority of them frame the problem as a binary classification one. And in addition to this, one paper utilized sliding windows to compute measures of customer lifetime value. And lastly, another paper discussed the development of a dynamic programming formulation for allocating contacts to customer segments. They, however, did not provide any method to derive these customer segments. So the gist with the research is that they only give us an idea of who we should target, but not really specify how often we should make contacts to these customers. Right, so onto the mathematical formulation. So we're going to assume that we have a set of customers, each having a set of features. And we're also going to assume that customers with similar features, and they can be classified as being in the same customer segment, they have the same probability distribution of acceptance for the product. So our objective is to now determine which customers to target first and how many contact attempts we should make before giving up. And we're going to give an example concerning one customer segment. So let's suppose we have n customers, and each of which features identical to those in the concerned customer segment. We assume that each customer is going to accept the probability of the product, but probability P sub I, and it's going to be made on the ith call. So if we make a maximum of k calls to each customer, we will let S sub k denote the expected number of successes, and C sub k denote the expected number of calls. So in this slide, we present two equations, and they essentially denote the expected number of successes as equation 1, and equation 2 denotes the expected number of calls. So I won't delve much into this. Right, so if we consider the function S sub k versus C sub k as we vary k, the gradient of this function is going to be given by equation 3. And what we can take away here is that in practice, P sub k is going to decrease while we increase k. And this would imply that once we make successive attempts towards a customer, the probability of them purchasing this product or service is going to be a bit less likely. Right? So consider the piecewise linear function with values at points C sub k and S sub k. So the gradients of the successive linear components will be decreasing, and as I mentioned before, this would eventually result in a piecewise linear concave function. So once we increase the maximum number of calls for one customer in a customer segment, we would do it for all customers in that segment. Now, optimizing over multiple customer segments would imply that we'll be solving a convex optimization problem. And this approach is commonly known as the waterfall approach. Okay, so a bit more into the formulation. Essentially here, we're going to let X sub j denote the number of calls that are assigned to customer segment J. We're going to let T be the total number of calls that we have access to allocate to these customers. And we're going to let S sub j of X sub j denote the expected number of successes if we allocate X sub j calls to the customer segment G. Okay, so this piecewise linear concave function that we mentioned previously scaled by the number of members in J. So the optimization problem effectively becomes the maximization of the number of successes for each customer segment. And we're going to keep in mind that we have a limit on the number of calls that we could make towards each customer. Right, so that's denoted by equation 4. Okay, so here we present the algorithm for call allocation optimization. So to the right there, it's in very much detail, but I've summarized that algorithm to the left there. So the 3 main points is that we're going to find, well, we're firstly going to find the customer segment with the largest gradient and assign as many calls as possible to get to the next breakpoint. Upon reaching that breakpoint, we're going to update the gradient for that customer segment, and we're going to repeat this procedure until we allocate all possible calls. So here we have an example of what was just mentioned before in the previous slide. So let's assume we have 2 customer segments, CS1 and CS2. And for each segment, we have the probability of success for each call. So P sub 1 for customer segment 1 is the probability of success is 0.1. And in CS2, the probability of success is 0.06. Okay, so assuming a limited budget of 680 calls, we should make at most 2 calls to those in customer segment 1 and at most 1 call to those in customer segment 2. Why exactly? So again, if we look at the probabilities, it's ideal if we look at customer segment 1 first, because it's the probability of having a success on the first call is the highest, it's 0.1. So once we allocate those calls, we could update the gradients. So the gradient is now 0.07, and it's still higher than making 1 call to customer segment 2. So we make our next call to customer segment 1, after which now the next best possible step we could take is allocating calls to customer segment 2. So that's why we allocate 2 calls to customer segment 1 and at most 1 call to those customers in customer segment 2. Okay, so on to some numerical results. So there's a bank marketing dataset, and it was collected by Moro et al. And the dataset concerns customers from a Portuguese banking institution and the use of direct marketing campaigns to encourage subscription to a term deposit product. So there were a total of 45,200 records, and each record represents a customer contacted during a marketing campaign. And the dataset comprised a lot of features. So there were mainly customer demographic information. There were some economic indicators, they were ignored. And in addition to that, there was also some data concerning previous campaigns. That was also ignored because there was a lot of information that was missing in these features. So the approach could be summarized by the figure 2 here. So we are effectively going to load and transform the data. Then after that, we'll build the customer segments. Afterwards, we'll assign customers to certain segments. And given some new customer, we can determine which customer segment they are assigned to. And based on certain metrics computed about the customer segment, we can determine or decide whom to call and how often to call them. Okay, so again, to note, our performance metric is the success per call rate. And we're going to use feature selection to determine which features would influence the metric the most, right? And this will determine the customers that we should approach. So we're going to compute this metric for each value of a feature. And in some cases, features contained many values. So in the next slide, you'll see an example. And one way in which we reduce the number of values for the feature was that we utilize the k-means algorithm to aggregate these values. And in conjunction with this, we use silhouette analysis to determine the ideal number of clusters. So this approach would not be feasible for all clusters. So some of them already have a small number of values. For example, housing loan, whether they had a housing loan or not. And in some other cases, features were continuous. So like age and balance, we couldn't really apply this aggregation towards those features. So in this slide here, we present the way in which we grouped or formed clusters for the occupation attributes or the occupation feature. So there were approximately 12 occupations listed in the data set. And after applying the k-means approach with silhouette analysis, 2 clusters were identified as being optimal for this. So the second cluster actually grouped student and retired as being 1. And that's because the success per correlates for those particular values there within the feature were very similar. And then the rest of occupations were grouped into one other cluster there. Okay, so we utilized 5-fold cross-validation to evaluate our approach. And for each cross-validation fold, we essentially use the training setting for the aggregation of the education, job, and marital features. So job, essentially, we discussed before. Education was based on primary, secondary, and tertiary education. And marital features, the attributes for that data was single, married, and divorced. So afterwards, when we determined the aggregation of those features, we then generated all possible customer segments by all possible combinations of groupings across all features. And after assigning the customers to the various segments and performing relevant computations, we then considered the test set and performed the evaluation previously described in the algorithm a few slides before. So figure 4 illustrates the piecewise linear concave function for customer segment A. And as you can see, according to the figure there, it's not exactly concave. So in order for us to apply all the optimization approach mentioned before, we need to replace this function with this concave hull. So what is based on data is defined in blue. And after applying the concave hull to this function, we obtain essentially the red line there. Okay, so I get more into the results. So after deriving all possible customer segments, there were 960 segments in all. And of those, 661 segments contain no customers. We then noticed that customers who had an existing loan have lower success per core rates. An exception to this was observed in customer segment 2, where persons did have an existing loan and the subscription rate was still high. So we noticed that they have high account balances. So essentially table 2 gives a kind of summary of the various customer segments that we found or that we obtained, and we sorted them kind of more or less in descending order, right? So within these segments here, we kind of list out what the age and balance grouping were, as well as the other groupings for the rest of features as well, and then what the values were for risk, personal loan, and housing loan. And then we have at the end there in the last column the success per core rate. So again, a lot of segments were empty because again, we only had 45,000 customers to distribute amongst 960 segments. So the majority of them were empty. Right, and from this here, we actually could derive some meaningful information as to why success per core rates were higher and lower for certain features based on demographics. Right, so to go on to the performance we achieved. So combining performance across the different cross-validation folds were difficult because in some cases we had a different number of calls and successes for each fold, right? So we decided to compute the area under the curve for each approach to measure the performance. So we essentially have 3 approaches that we want to compare. The first approach is the baseline approach, and this is essentially calling all customers in our data set, the test set, randomly, right? And noting the successes and calls as we execute the calls. The second approach is based on the approach we mentioned, and it's the greedy customer segment approach. And it's effectively would involve us forming those customer segments and then determining the successful call rate for that customer segment. And once we have that information, we could use that to order or prioritize how we will call customers in the test set. And that's denoted in the orange line. And lastly, we have the gradient ascent approach. So this takes the optimization a bit further, and you'll notice that this has the best performance. So what we did is that within each customer segment now, we optimized how much calls should be made there to certain customers. So within that now, we got an additional improvement of 4%, and our improvement over the baseline again was in total 38% improvement. Okay, so just to note as well, the age and balance groupings were treated as hyperparameters for the problem. So we had to run a series of simulations until we obtained the best improvement over the baseline. And the optimal values for age and balance we found were as follows. So we have it listed there for age and balance. Age, we had 5 groupings, and balance, there were more or less 3 groupings that led to the optimal results. So one thing to mention as well, the UB, which is defined in red, it denotes essentially the upper bound to the solution. So this essentially means if you were to know how much cost to allocate to a customer and whether or not the customer would subscribe to the product or service, this would effectively indicate the best performance possible. Sorry. So again, we have a lot of room or a lot of headway to make in improving the performance. Okay, so in terms of the conclusion, the results indicate that implementing our proposed method will increase the success of telemarketing campaigns with a limited budget of calls. A segment of this work was actually applied at a banking institution. So this was the CIBC research grant, and experiments conducted with historical data at the institution showed that we had an 8% performance improvement when compared to the baseline approach. So in terms of future work, we are currently in the process of evaluating our method against machine learning approaches. So effectively, we could take that approach to forming the customer segments and give it towards a machine learning approach. And initial experiments reveal that the application of the clustering algorithm, or a clustering algorithm, sorry, towards the formation of segments would improve the success beyond the gradient ascent approach we had in one of the graphs previously mentioned. So we also exploring the use of a hybrid approach, and where we utilize both the prediction and clustering algorithms in order to achieve better performance. Okay, so that, right, so this last slide here presents the improvements at the banking institution in the CIBC research grant. And effectively, the orange line denotes the performance or the success captured with no optimization. And that was effectively randomly chosen persons in the test set. And with our approach, we had to modify it a bit differently, but effectively we were able to obtain at most, I think, an 8% performance increase over the non-optimized approach. So this brings me to the end of the presentation. I could open the floor now to any questions. Thank you. I'll stop sharing.
Yeah, thanks, Shiva. Nice presentation. Yeah, I have no questions. Naturally, I have no questions. But one thing I have realized is this issue of computing a derived statistic from categories is turns up in a lot of places, and so this was one place I saw it with this banking stuff. It came up with some other stuff we did with insurance. It came up with something else I was looking at as well. So that's something I'm looking at as well. The issue is this, you could cluster things, but when you cluster things, you have to take into account the robustness of the derived statistic as well.
Yes.
So if you have fewer clusters, you have more data per cluster. So it's a more robust estimate.
Correct, yeah.
But because you have fewer clusters, you have lost some of the distinction,
yeah.
The individuality. So the question is, what is the optimal trade-off between those two? So it's an interesting problem. But yeah, thanks, Shiva. No more questions for me.
Hi, Nick.
Yeah, Shiva, good presentation. I was wondering, so for
Thanks.
banking, is telemarketing the best medium, like right now, calling people?
Well, it's the most personalized medium, but we realize that in the case of these institutions, right, and many companies as well, sorry, they make a lot of attempts with various methods, right? So sometimes it might be useful to use email, you might use telephone calls. It's better to probably do advertisement towards a large segment of the population via a banner. So there are a lot of mediums one could take to advertise to customers and kind of entice them in the product or service. But in this case here, the data that we restricted to was that it only had telephone calls. And I guess the reason that the bank in Portugal, did this method is because it's the most personal. So they would have information based on the customer, and I guess they would kind of more or less tailor that phone call to kind of suit them and kind of explain why they would need the product or service. But a nice thing too would be to kind of incorporate the metric and so on and the work for multiple contact mediums as well.
Yeah, I was just wondering, well, I guess, God forbid anybody call my phone, but if it's your bank, if it was my bank, yeah, I would definitely answer. So if it's so I guess they would advertise to their own customers as opposed to, but I guess that's the only people they would call. They wouldn't call random people.
So with the campaign, you would tend to focus on your customer base, but I guess like with ads and flyers and whatever, you could reach a more wider audience that's not within your customer base. Yeah.
All right. Cool. Thanks.
No problem.
Hello.
Anyone else? Hi, Nirvan.
Hey, yeah. So in one of these slides, you were talking about the customer segments, and maybe I just got lost in terms of what is a customer segment, but you also mentioned that some segments had 0 people.
Yeah.
How is that possible? How does that
I'll
look like?
reshare these slides. So this was here, more or less, right? So
Yeah.
again, the customer segments were formed by all the possible combinations of values across each feature. So let's just say we had 2 features. So we had the marital status of the person as well as their age, right? So marital status took on, well, in this case here, 2 groupings. So when we apply the k-means clustering to determine how to aggregate the values within the feature, we realized that with marital status, again, it actually had single, married, and divorced. And from applying the k-means optimization, we found that it's useful to describe or group single and divorced persons. So that's one group there within the marital status, and then the other would be married persons, right? So that's 2 possible groups you have there. Now, if you look at age, I think I mentioned somewhere at the end, we had 5 age groupings. So taking those 2 features into account, we have 2 possible groups for marital status and 5 for age, and 2 times 5 is 10. So we'll have 10 possible groupings across the entire data set for age and marital status. So we actually did this for all the features. So age, balance, education, marital status, and so on. So that's why the number of customer segments was so large, right? Because it considered all possible combinations. So the reason why the majority of them contain no customers could be the fact that there were no customers with that particular combination of the features that allowed a customer in the test set to fall into that customer segment.
Right.
Does that kind of clear up some more?
Yeah, that makes sense.
Yeah.
Did you guys do any extra, let's say, trimming of some segments that is kind of impossible? So I'm guessing some might be impossible, right?
Yeah, so we effectively ignored those 661 segments because no customers fell into those segments. In terms of trimming, we didn't really apply any approach towards like, so you're kind of talking about grouping some customer segments together.
Yeah.
Right. So we didn't apply that there, but in the k-means approach, just to give some insight into what's going on there. So with the k-means, we're trying different numbers of clusters. And well, so far, I think I've tried up to about from, I think 15 to about 25 clusters, I think. And so far, based on what I'm seeing is that as we increase the number of clusters, so in this case here, the numbers of clusters are much smaller as opposed to the 300 and something that we have, or it's nearly 300 that we have from applying the initial segmentation approach. So with k-means, it's a bit more, it's less granular for sure, but it's a bit more robust as processed because we have more data for these customers here. So I hope that kind of clarifies the question that you have. Yeah.
Yeah, thanks. Good presentation. I saw
Thanks.
the paper on the website, so I'll probably try and read it when I get a
Yeah,
chance.
no problem.
All right, thanks.
Okay, no problem. Any more questions?
Shiva,
Hi.
hey, so the reason for using the segments as all the possible combinations of the features there, was that
Right.
just for completeness, or is there maybe other reasons that you would use so many segments?
So this was one way, and it was, I guess it was the most naive way initially, and that kind of remained there. But the optimization would actually be determining how we could combine customers' segments together. So that is the result of the extended work which we're doing right now. So it's just simply
Okay.
all possible combinations, and then whatever happened, we just looked at where the customers fell into and analyzed those segments.
You think high level segments, just based on someone who knows the customer base, you think maybe about 10 segments might give comparable results?
So actually, when we apply the k-means approach, so when I mention k-means in this context here, it's a bit different. So we utilize k-means to form clusters instead. So instead of applying k-means for determining how we could aggregate certain values within a feature, we applied k-means to determine what is the ideal number of clusters or how we should form clusters for the entire customer base. So I think with 20 clusters, and I did the same more or less approach where we segmented into those 20 segments and applied the same algorithm more or less essentially, the performance increased quite a lot as opposed to our customer segmentation approach in the paper here.
Okay, all right, thank you.
Yeah, no problem.
Great presentation.
Thanks.